Good morning, good afternoon, good evening. Today I'll be showing you how to make remesh node groups that are essential for making 3D text effects. In this channel, I've been covering how to make various text effects, but it has all been 2D. It was due to the fact that official Blender is lacking this text remesh functionality. I made this remesh node group about half a year ago when Repeat Zone was introduced in 4.0. But with 4.3 approaching and no similar functionality by the foundation in sight, I've made up my mind to share this on my channel. As I said, in order to proceed with 3D text effects, being able to remesh is a must. However, once made, we will be able to combine it with pre-existing functionality to quickly generate cool looking effects. So I think it is worth all the time and effort. Alright, let's get into it. So, before touching the node tree, let me explain why remeshing is required for 3D text effects. First off, remeshing is not quite necessary if your 3D text animation only requires simple operation like translation, rotation, and scaling. However, remeshing is needed if you want to 1. Add deformation like bend, twist, squash as a part of effect, or 2. Use simulation like soft body and cloth. When deforming mesh, clean topology is needed to avoid shader artifacts. If regular triangle fill is used to create faces from text curve, there will be triangles with various sizes forming the surface. When there is large amount of deformation like this twist effect, you will end up with noticeable amount of shader artifacts. Remesh will solve that issue. Influence of bad topology for simulation is way worse. Square-faced mesh with near uniform vertex distance is highly desirable for simulation, since most Blender physics simulation uses vertex-based solver. What you're seeing now is in letter O inflated with cloth simulation. As you can see, the shape of remeshed O on the right stays intact during simulation, but the left one with triangle mesh deforms awkwardly. Alright, so experienced Blender user might be thinking, why not just use voxel remesh? Well, in case of text mesh in particular, voxel in my opinion is not the optimal solution. Since most letters in alphabet utilizes a bunch of curves and voxel cannot recreate such curves without massively increasing resolution, before you know it, you will end up with millions of polygons not suited for animation purpose. The geometry node remesh that I'm introducing will have square faces like voxel remesh, but will be able to sustain the curved edges, which is perfect for 3D text effects. Alright, let's get started. Alright, as soon as we get into Blender, we'll hop right into geometry nodes layout, A to select all, X to delete. Shift A, add mesh plane. Using numpad 7 and 5, go into top orthographic view, click on new, delete group input, replace it with string. Type in test, pass it through strings to curve, then output. Right, so we'll start off by the most basic conversion, which is converting the curve instance into grid mesh. Right, so let's start off by realizing instance. Add a bounding box. From max, pull out a vector mass. Change it to subtract and subtract min. Then separate XYZ. Then from X, pull out a grid and plug it into size X, plug Y into size Y, and we will end up with a simple grid. Right? Let's set the resolution and add a value for it. I'll just rename it resolution. And let's for now set 0.1. Then from the result of subtract, pull out a vector mass divide. Divide it by resolution. from divide, vector mass add 1 to all direction, separate XYZ, then plug the X into vertices X, Y into vertices Y. Right? So we've ended up with a grid of resolution 0.1 of the size of this text. Right, so now we got this grid, but the location is offsetted, so let's correct that. Well, first off, select the subtract, Control Shift D to duplicate with connections, bring it up, change it to add, then vector mass scale, and scale it by 0.5. Right after the grid, add a transform geometry, and grab the result of scale and plug it into translation. Now the grid is covering the text, but in order to take a mesh boolean, we want the grid to be a little bit larger than the text. So I'm gonna insert 1.001 into scale of transform geometry. Right, now that is done, let's grab the text mesh. From here, we'll grab a fill curve and proceed with N-gon fill. Then using extrude mesh, I'm gonna extrude mesh. I'm gonna give it a volume. The reason for this is when we do a mesh boolean, if we have two plane taking mesh boolean, it's not really gonna work. So I'm gonna give it a little volume to the text mesh. All right. Next, add a mesh boolean, change the type operation to intersect, and change the solver to exact. I think this option was added in 4.2, but yeah, we want to keep it as exact. Right, let's take the mesh boolean of transform geometry and extrude mesh and output. Okay. So now we have this text grid mesh with this resolution. Of course, if I were to change the value to 0.01, we'll have a finer grid size. Okay. Right. So what I'm gonna do is move this resolution over here and grab all the nodes starting from realize instance all the way to mesh boolean, and Control G to make it into a node group. Open up the side panel with N. I'm just going to start renaming the input sockets. So this geometry is going to be curve instances. I just want to make it, well, clarify what type of input it is. The next one is going to be resolution. And the type is going to be a float. And let's set the default value to be 0.1 and min to be 0. Right. I'm gonna move it around. I'm gonna connect these up. Alright. Oh, it looks clean, so let's tab out of it. And I'm gonna call this node group remesh CI for curve instances. Right, so 2D remeshing is pretty much complete, except this is a little bit inconvenient because all the points are in meshes and we can't really tell one letter from the other. So what I'm gonna do is I'm gonna separate out all these meshes and turn it into instances per letter. Okay, So the first thing is I'm going to grab a separate geometry, change the domain to instance. From selection, pull out a compare equal, and from A, I'm going to pull out an index. Now we only have this T, so I'm going to use a geometry to instance node to convert it into one instance. I want to repeat this step for the rest of the string, so I'm going to use a repeat zone. Spread it apart like so, and in the node tab I'm going to add an iterator of type integer. From the iterator I'm going to add 1 and connect it to the output like so. Okay, I'm gonna drop a join geometry on this line, and from geometry to instance I'm gonna drop the line to the bottom of the socket. There's gonna be 2 slots, so I'm gonna drop it in the bottom. Okay, just gonna reconnect it to the output. Then from the iterator I'm gonna draw a line to compare equals B like so. Okay, for the number of iterations it's going to be the number of text, so I'm going to grab a domain size from curve instance, change the domain to instance, and plug in the instance count to iterations like so. Okay, right, so like I said, all these letters are going to be separate instances, so it's a little bit more useful. Of course you can always realize instance and turn it back into mesh. Okay, all right. I'm gonna grab all these from domain size to repeat and Control G to make it into a group. I'm gonna start renaming the inputs. Geometry is again curve instances, and since the resolution and curve instances is flipped around, I'm gonna reorganize it. Then reconnect like so. Maybe using some reroute. Clean it up like so. Okay. Let's check out the default value. So resolution, I'm gonna set it at 0.1. Okay. Right, let's go back out, and I'm gonna call this remesh text 2D. Cool. So text remeshing for 2 dimension is complete. So I'm just gonna alt drag this out and start working on 3D remeshing. So let's go back and add remesh CI, the one that we built first, and drop it on here. So since it's going to be a 3D text effect, what I'm going to do is, well, first add this resolution back. As a matter of fact, I want to do it with 0.1 first, so I'm just going to change it to 0.1. And since it's 3D, let's start off by using an extrude mesh. Okay. Click off this individual, and as you can see, the extrusion is done, but what I want is loop cuts going all the way with the same resolution step. Okay. So what I'm going to do first is just plug this resolution into offset scale like so. So now we have this 0.1 Blender unit high text. But let's say we wanna get it to 0.5 meters, right? 0.5 meters, so we wanna be able to control the extrusion offset. So let's just grab another value node. I'm just gonna rename this extrude offset and gonna set 0.5 in it, right? So the way I'm gonna make loop cuts is basically I'm gonna stack up the extrusion to as many times as I need to. So what I'm gonna do is grab a repeat zone and I'm gonna reconnect like so. Okay. And if I were to increase the iteration, well, it's not gonna extrude upwards because it's gonna extrude in all directions. So what I can do is grab this top, plug it into repeat, and go back to the input part and grab this top and put it into selection. Then if I were to set the initial value of top to true, then now I can increase this iteration and just stack one on top of each other. Okay. Right, so like I said, I want to be able to extrude to 0.5. So what I'm gonna do is grab the extrusion offset and plug it into divide it by resolution to get the amount of iterations required to get to 5.5 meters. Okay. All right. So it's fine and dandy until we have values like 0.55, which since this input iterations is in integers, it's not going to be dealing with a remainder. So I'm going to add a little bit more logic beforehand. So what I'm going to do is make a space between remesh CI and extrude mesh, repeat. And I'm going to grab this extrude mesh, duplicate it, and bring it over here. Then gonna grab this top and plug it into repeat top. And it's gonna look like this. Then with this divide selected, I'm gonna use Control-Shift-D to duplicate with connections. Change the operation to floored modulo. Then connect the value into offset scale like so. Okay. So now what's gonna happen is it's gonna extrude by 0.05 the remainder part first, then it's gonna stack it up 5 times like so. So it ends up as 0.55. Okay. So if I were to change this to 0.18, same thing. It's gonna do 0.8 first, then do a 0.1 next. Okay. All right. Cool. So we got the extrusion part done, but if we go back to solid view, we see that there's this it's not capped. Basically, there's this huge hole, right? I think it's how this extrude mesh works in geometry nodes. It's a little bit different from the regular extrusion. If you extrude a flat plane, I think the original plane is lost. So what I'm gonna do is cap it by using a join geometry and connect the remesh CI into join geometry like so. Okay. So now the hole is gone, it's capped, and it looks like a manifold, except if I were to turn on the face orientation, you can see the normal on the bottom side where we just capped is going the opposite direction. So what I need to do is use a flip face and plug it in here. after the remesh CI to get the normals back to outside again, facing outside. Right. Before I move on, I know that these two, well, the cap part and the extruded part, they're not actually joined. Well, they are joined, except they're not welded. So what I'm going to do is merge by distance and connect these two up. Okay. Right. Great. So the basic part for 3D remesh is complete. So grabbing this remesh CI to merge by distance, I'm going to Control G to group it up. Let's check out the input socket. This value is extrude offset. Let's set the resolutions fine, extrude offset's fine, curve instance, right? Looks all clear, but since the connections look kind of messy, I'm gonna duplicate the group input and clean it up like so. Okay, so these go like that. This one and this one. So make sure when you do floored module and divide, extrude offset is on top and resolution is on the bottom. Okay. And lastly, this offset scale is resolution. Okay. Great. Right, so let's tab back out and call this remesh CI 3D. 3D. Okay. Just like we did with the remesh text 2D, what I want to do is make these individual letters into individual instances. So just to cut corners, what I'm gonna do is duplicate this remesh text 2D, make it into a single user, and rename it to remesh text 3D. Okay, so these two are now different. Go into remesh text 3D and grabbing this remesh CI, I'm gonna go to the drop down and select remesh CI 3D right here. Okay. Then I'm gonna connect this extrude offset into a empty socket for group input, like so. Okay. Right, so now I can delete this guy, and we have 2D remeshing and 3D remeshing. Let's set the resolution, so let's get up here. Right. So this one's 2D remeshing. Okay, and this is 3D remeshing. Okay. Right. We aren't going to be making any particular effects today. The purpose of this video is to make these two node groups. So what I'm gonna do, what I'm gonna proceed to do is turn them into assets. So right click on this shield and go down to mark as asset for both of these node groups. And when you save this blend file, make sure to save it into your asset libraries path or any kind of subfolder within this asset libraries. And if you do that, you will be able to access the node group through the asset browser. Okay. Right. So make sure you mark them as assets, and since I'm going to be using these remesh functions for future videos, I want for you to be able to pull them out easily. Okay. Alright, so let's take a look at what we made. Let's go into 2D first. The core of this functionality is basically this remesh CI, right? What we did is basically make a grid with particular resolution, took mesh boolean with a text. So we have a text with a grid mesh. Okay, let's hop back out. And this is remesh text 2D. We've separated them into instances per letter, so it's a little bit more useful. Let's hop back out and let's take a look at the 3D remeshing. So for 3D, let's take a look at remesh CI 3D, which is right here. We start off with remesh CI. We basically extrude them out as many times as we need to fulfill the extrude offset. Then cap it off with the original remesh CI. Okay. Let's go back out and we do the same thing as we did with 2D. We are basically making one letter into, well, it mesh per letter instance. Okay. Right. So, well, like I said, the purpose of this video was to create these two remeshing functions or node groups. In the future video, I'll be introducing how to make 3D text effects, especially with simulations and deformations. So I hope you can join me in those videos and hope to see you next time. Bye.